Hello guys, welcome to my channel. So today our code is reverse the array. So which is a very important in arrays and the basic code that everyone have to know. Okay. So in this code what I'm doing, generally I'm taking this input. So what is the input? 1, 2, 3, 4, 5, 6. Okay. So I have to reverse it. Reverse it means what is the general thought? What you can think general thought? That is 6 should be come to the first place. Alright. And 5 should come to the second place. And 4 should come to the third place. And whenever my start is equals to end, I'm not doing nothing else. Would you able to understand? So here there are 6 numbers. Suppose if I take until 5. If I take until 5. So if I take until 5. Okay. So leave it about 6. Okay. In general I'm saying. So how to do for odd numbers. So in odd numbers, what is the thing you will get? So 5 numbers, right? You have to swap each and every start and ending element. So see, 1 should be swapped with 5. 2 should be swapped with 4. And 3 should be left like that. Because there is no number to swap. Because start becomes is equals to end. So in general, I'm using here start and end pointers code. So by using this algorithm, you can just apply to any C++ or Java or Python. Okay, this is a basic thing what I'm explaining, which will be same for every language. Okay, so there are 3 approaches which we can do. So this is a first approach, best approach, optimal approach I can say, which takes O of n time complexity. And here you can observe that there are 3 methods. There are 3 methods. First one, using the start and end pointer also we can use this. We can do this reverse array. And using the extra array, that means which takes extra array, extra space complexity also, we can take that array also, that method also. And there is another one reverse inbuilt method we can also use. But I'm not talking about those 2 logics because this is the most optimal one. So which everyone can understand easy and yeah. So according to time complexity and space complexity also, it is very, very perfect. So the basic intuition I have explained already. So what is it? Index 0, it should be at index last position, and the index which is at index is equals to 1, it should be like n minus 2 position. Okay, so yeah, my start pointer would start from here generally. Okay, in general my start pointer would start from here, and then my end pointer will start from here. Okay, all right, yes. So whenever it is started from this position, this is my start and this is my end. Would you get it? So start is equals to 0 and end is equals to what it's going to be? N minus 1, where my n is equals to array dot length. So in general I'm taking here array dot length. I'm not implementing any n extra variable for that. In general I'm taking that, but you can use in code. Okay, so using while loop until my start is less than end. Until my start is less than the end, I'm moving this. Okay, so let me explain this. So after that, so yeah, start is equals to 0 and end is equals to array dot length minus 1. While my start is less than the end, obviously here 1 is less than 6, right? 1 is less than 6, right? So that's why I'm using the swap algorithm. So have you heard about swap algorithm? So here we are taking a temp variable, and if it is yes, if my start is less than the end, if my start index, here we are talking about index. Okay, so 0. So 0 is obviously less than my last index. That is what? That is what? 0, 1, 2, 3, 4, 5. This is the 5th. Okay, so I is equals to 5 here. So obviously 0 is less than 5. So that's why it goes to the swap algorithm. It goes into the function. It goes into the loop. Here we are taking another temp, and we are storing that start variable. That is 1 we are storing in the temp. In the temp we are storing 1. Okay, so in the temp we are storing 1, and after that, so what I'm doing, this is a temp. This is my temp variable. In general, yeah, I'm storing in my temp my start variable, that is 1, and after that my start array of start position is swapped with the array of end. What is that? What is that? 6. Alright. So that position, my start position is get swapped with the end position, that is not position, element, it is swapped. Okay. So that's why I'll get 6 at one position, first position, and the remaining elements would be like this. Okay. So after that, what I'm going to do, I'm just updating my start and my end also I'm getting updated, because these two should be swapped, right? Obviously these two should be swapped. And again I'll check whether my start is less than end. So now what is my start position? Start position is I is equals to 1, and end position is, what is that? Yes, n minus 2. Yes, obviously it is less than, right? So this is I is equals to 2 and this is I is equals to 3. Obviously I is equals to 1, I is equals to 3. So sorry, I is equals to 4 here. Alright, I is equals to 1. So obviously these index are lesser. Then I'll swap these two also by using the swap algorithm, as you know. And my again temp will be replaced with the 2. Okay, because my the position element is 2. Obviously I'm swapping, and again I'll increase my start and decrease my end. Again I'll do the same until I get my start is less than end. So when my start increases this position, so at a certain position my start will be increased, right? At that position the loop wouldn't take it, so it will come out of the loop and it will print my array. For printing only we are using here time complexity, that is O of n, big O of n, and the extra space complexity what is using is big O of 1. And generally it takes, in general, because array takes O of n algorithm, okay, O of n space complexity, but here interviewers ask about extra space complexity, not the inbuilt space complexity which is required for that problem. Okay, so that is of one time complexity it is taking. So this is the best approach you can follow for reversing an array. I hope you understand. Thank you for watching.